Well, hello, my 30-2 friends. Okay, this video is going to begin the rational expression and equations unit. Now, in 30-2, I would probably say this is the hardest unit, okay? So some schools start with this right away so that we can keep emphasizing some of the concepts throughout the whole course with you. Other schools kind of start you off on an easier note and then hit this at you a little later on. So whenever you are, wherever you are in this unit or in this course, this is going to be kind of the trickiest, I think, unit to do. Now, partly because it has two of your favorite F words involved. Factoring is the first one, and fractions is the second one. And so rational expressions and equations kind of marry together both these concepts of factoring and how to do mathematical operations with fractions. Okay, now, as our first lesson in this unit, what we want to do is just go back and review factoring and make sure you guys are feeling really, really solid about factoring before we get into using it in rational expressions, okay? Okay, so just as a reminder, factoring means to make a multiplication sentence, okay? Um, in grade 10, you were given all these questions that had brackets that you had to multiply the brackets together. And those questions said expand and simplify. That was taking a multiplication sentence, doing the multiplication, and then having an answer that didn't have brackets in it anymore. Factoring is the opposite of that. We are going to take a statement that would be like addition or subtraction, and we're going to turn it into a multiplication sentence. So we're going to introduce the brackets this time so that our answer should have brackets. Okay. So if you think of 2 and 3 are considered factors of 6 because I can break 6 down into a multiplication sentence that says 2 times 3. Okay, so I am factoring 6. I am creating a multiplication sentence by saying 2 times 3. Okay, so what we want to do here is just give you a bunch of factoring questions. We want to completely lambaste you with factoring, okay, just as a means of review. So the question is going to read, completely factor the following, okay? So I might look at this and say, okay, well, what is common to both 6 and 18? I know a 3 is common to both 6 and 18. So I could say, okay, I'm going to pull out a 3. And what would that be left with when I divide both of those guys by 3? Well, 6 divided by 3 is 2, so that'll be 2x. And then 18 divided by 3 is 6, so that'll be negative 6. Okay, that's a great factoring question. I could also look at this and say, hey, actually, I could say 6 is common to both. So if I took out a 6, what would that look like? Well, now I'm dividing by 6 each time. 6 divided by 6 would just leave me with x. And then 18 divided by 6 would leave me with 3. That's also a great factoring question. But the question said to completely factor. Completely factor means I want to take as much as I physically can out. So that means the better answer is this guy. This is not completely factored because if I looked inside here, both of those are still divisible by 2. So I didn't take out the biggest number possible. Okay, that's what we mean when we're saying completely factor. So for 6x minus 18, I can take out the 6, and then I'd be left with x minus 3. Now, I can check myself by thinking about what would happen if I multiplied this, right? 6 times x gives me 6x, and 6 times neg 3 gives me that neg 18, okay? So I haven't actually changed the question. I just made it into a multiplication statement instead of an addition subtraction statement, okay? All right, let's go again. 2x squared minus 12x. So you can think of 2x squared if you like, sort of like this, 2xx, because x squared is x times x, minus 12x. So when I'm looking at these piles, I know that there's a 2 common to both, okay? And there's 2 x's here, there's 1 x here. That means there is 1 x that's common to both. So actually, I can take out an x as well. Okay, so what am I left with when I take out that 2x? And when I say take out that 2x, we're talking about dividing out the 2x, okay? So if I divide this guy by 2x, I'm left with x. And if I divide negative 12x, remember you want to take into account the sign that's in front of the number. So we don't look at that. I mean, it is subtract 12x, but when we're thinking about it, we think about it as a negative 12 so that we think, okay, a negative 12 divided by a positive 2, that's going to give me a negative 6, okay? Now, x divided by x is 1, so I won't have an x on that term anymore, okay? So that'll be 2x times or multiplied by x minus 6, okay? All right. 3x squared minus 9. Very similar question to what I did. Oh, by the way, I haven't said this yet, but hopefully you're pausing me and you're actually trying these questions yourself, right? That's how you're going to learn the best. Don't just listen to me drone on and on and on. I help with math and insomnia. If you ever have trouble sleeping, just turn a video on. No, but make sure you're pausing me, trying these yourself, and then coming back and checking how I did it and comparing notes with me, okay? So 3x squared minus 9x, greatest common factor there is 3x. So then if I take out the 3x, I'm dividing this guy by 3x, I'll be left with x. I'm dividing negative 9x by 3x, and I'll be left with negative 3. So 3x times x minus 3. Okay? We got this. Factoring is not scary. Okay, 6x squared minus 8x. So what's common to both of those? Well, with 6 and 8, there's a 2 that's common to both. And then x squared and x, we've been dealing with that for a couple questions here. 1x would be common to both. So what's common is 2x. I'm going to pull that 2x to the front and divide out. So when I divide out 6x squared by 2x, whoops, sorry, that's going to leave me with 3x. And then when I divide out negative 8x by 2x, that's going to leave me with negative 4. Now, this is a great conversation to have, thinking about the fact that we're dividing here, right? But I see lots of kids make a very important mistake. When they're doing this, they forget that that 2x still has to be in the front. You can't make that 2x just magically disappear, okay? You're pulling it to the front in order to create the multiplication sentence. So final answer will be 2x times 3x minus 4. That was kind of a bad 4, sorry. Okay? Awesome. All right, 15x cubed minus 5x. What's common to both of those? Well, actually, 5x is common to both of those. Now, great little conversation to have here. And the question is, when I take that 5x out, what am I left with? Well, I know that 15x cubed divided by 5x, that's going to give me 3x squared. Now, if you're unsure of that, let's just look at it for a second. I'm dividing by 5x, right? So 5x is coming out to the front. 15 divided by 5 is 3. X squared divided by x, that's like a power, exponent laws where we are subtracting powers of the same base. So 3 minus 1, essentially, that'll give me an x squared. Okay, or if you want to look at it this way, it's like xxx divided by x, and one of those x's divide out. So you'd be left with 2 of those x's. Okay, now that wasn't the thing I wanted to actually talk about. What I want to talk about is the next term, because sometimes, not you guys won't do this, but sometimes I have kids who will say, okay, I'm done. I'm going to close the bracket right there. That is not correct. We have to think about what is 5x divided by 5x. What's 7 divided by 7, friends? 1. What's negative 8 divided by negative 8, friends? 1. What's 18 billion divided by 18 billion? 1. So what's 5x divided by 5x? 1. Now, technically, it's negative 5x divided by positive 5x, and so my answer will be negative 1. Okay, so 5x times 3x squared minus 1. It's important to remember when you're taking out a greatest common factor like this, the number of terms you start with has to be the same as the number of terms that are inside these brackets, okay? Yay. Okay. Whoops. Awesome. So remember, anything divided by itself is 1. The amount of terms inside the brackets should be the same as the amount of terms you started with. Okay. All right. 3x minus 9x squared. 3x minus 9x squared. I can take out a 3x. And then when I take that out, I'll be left with 1, right? 3x divided by 3x minus 3x. 9x squared divided by 3x would give me 3x. Okay, awesome. X squared minus 16 is next. This one is special. We learned it in grade 10, but that doesn't mean we remember it, and that's totally okay. This is called a difference of squares. It's a perfect square minus a perfect square. Now, the difference of squares look like this. Okay, so you have a squared minus b squared. And what happens is it breaks into two factors. Times themselves, like two binomials multiplied by itself, where the first term of both of my binomials is the square root of the original first term. And then the second term of both of my binomials is the square root of the original second term. Then one of them gets added and one of them gets subtracted. Okay, so if I set that up for this guy, I know I'm going to have two binomials multiplied by each other. Okay, the first term is the square root of x squared, so that would be x. The second term is the square root of 16, so that would be 4. And then one of them gets added and one of them gets subtracted. Okay, that's not scary, right? Okay, awesome. Let's try it again. X squared minus 1. Now, you got to remember here, 1 is actually a perfect square, right? So the square root of x, that's my first term, is, sorry, the square root of x squared is x. And then the square root of 1 is 1. So I end up with x plus 1 and x minus 1. Okay? Yay! Okay, 4x squared minus 9. We're still practicing the same thing, friends. This is still a difference of squares. Hey, I should clarify, difference means subtraction, okay? So if I had said 4x squared plus 9, that's no bueno. There's nothing I can do with that, okay? It has to be a perfect square minus a perfect square in order to think about difference of squares, okay? Okay, so the square root of 4x squared is 2x, and the square root of 9 is 3. And so that's going to be 2x plus 3 and 2x minus 3. Okay, 2x plus 3 and 2x minus 3. We're feeling okay? We're going to rock 30-2. It's going to be a good day. Okay, 4x cubed minus x. 4x cubed minus x. So on this one, what we're going to look at is, first of all, can I take out a greatest common factor? When I look at 4x cubed and x, I can see that x itself is a greatest common factor. So I'm going to pull the x out, and that's going to leave me with 4x squared minus 1, right? X divided by x is 1. Great. Remember, the questions say completely factor. So we're going to factor until we can't factor anymore. So I'm always asking myself, okay, is there anything else I can do here? And the answer is absolutely, friends, because, do you see it? This is the difference of squares. Okay, so that is now going to factor into the square root of 4x squared is 2x. So that'll be my front term. The square root of 1 is 1. Those will be my back terms. And then I'll have a plus and a minus, and life is good. Okay? Awesome. All right, then we get into trinomials. Now, with trinomials, there's a bunch of different ways you can factor, okay? I'm gonna walk you through what I think is kind of the most straightforward algorithm to factor. It's called decomposition. If your teacher has taught you something else and you're happy with what your teacher has taught, that is awesome. Go for it, okay? There's not one way to factor and there's not a right way to factor. As long as you're being able to show work and as long as you're able to get to the right answer, okay? So if I was doing decomposition here, I would be looking for two numbers that multiply together to give me my outside numbers multiplied together. So this is a 1 and this is a 4. 1 times 4 is 4. I'm looking for two numbers that multiply together to give me 4 and add together to give me 5. So I'm thinking about my factors of 4, 1 and 4, 2 and 2. Oh, 1 and 4 would add together to give me 5. So I know that that's my magical numbers here. Okay, so the reason this is called decomposition, decomposing means to break down. I'm going to take that middle term and I'm going to break it down into those two friendly numbers. So I'm going to write this as x squared plus x plus 4x. See, I broke my 5x into x and 4x. X plus 4x is still 5x, okay? Plus 4. Now, I'm going to take a look at this, and I'm going to factor the front two and factor the back two, okay? So if I looked at x squared plus x, what's common just to those two? Well, there's actually an x that's common to both of those. And if I took that out, I'd be left with x plus 1. Okay, what's common to 4x and 4? Well, that's actually a 4 that would be common to both of those. And when I took that out, I'd be left with x plus 1. Okay, well, now I get super excited because when I'm looking at this, and I tried to color code it for you, when I'm looking at this, I can actually see that now I have two different terms here, but x plus 1 is a common factor to both of those terms. So then I can pull the x plus 1 to the front, just like I'm factoring out a 4, or factoring out an x, or factoring out a 2, or whatever. Okay, I pull it to the front, and what am I left with when I pull that out? Well, I'm left with x plus 4. My apologies. That was me being silly. That should have been a 1. I want to keep my color code. There we go. So x plus 1 came to the front, and then x plus 4 is what's left. And so we have been able to factor this guy, x squared plus 5x plus 4, into these two binomials multiplied together. We created a multiplication sentence. That's what factoring is all about. Okay. If I wanted to check my work, I can totally do that. X times x is x squared. X times 4 is 4x. 1 times x is x. I'd add those two things together and get that 5x. And then 1 times 4 is 4. Okay, so everything jives, everything's cool. We are going to love the rational unit of 30-2. That was purely coincidental that I chose the same colors as what was on the PowerPoint slide. That was kind of amazing. Okay, x plus 1 and x plus 4. Good. Okay, so now let's just try that a couple of times, okay? See if we can get comfortable with that. So x squared minus x minus 30. I'm going to do it with you. We're just going to walk it through together. I'm looking for two numbers that multiply together to give me negative 30 and add together to give me negative 1. Okay, so I'm thinking about the factors of 30. So 1 and 30, 2 and 15, 3 and 10, 4 and nothing, 5 and 6. Hey, if you're uncomfortable getting those, you have this lovely little machine called a graphing calculator. Just grab your calculator, go 30 divided by 1, 30 divided by 2, 30 divided by 3, okay? Don't make your life complicated. You've got tools to help you through this, so make sure you use them. Now, I'm looking for a difference of 1, so that's going to be this guy, and then I have to decide who's negative. If I want to add these together and get a negative 1, the larger number here is going to have to be negative. So my pair is going to be 5 and neg 6. So I'm going to decompose. I'm going to break that down into negative 6x plus 5x minus 30. And then I'm going to take a look at just the front two and factor the front two, factor the back two. What can I take out of x squared minus 6x? I can take out an x. and I'd be left with x minus 6. What can I take out of a 5x and a negative 30? I can take out a 5. You just need to make sure you have either a plus or a minus there, depending on whether you're taking out a positive or a negative. There does need to be a symbol right here. Otherwise, you're communicating a bunch of multiplication that you didn't mean to, okay? When I divide that 5 out of these two terms, I'm left with x minus 6. Oh, look, both terms have an x minus 6. So I can pull that x minus 6 to the front. And then I'd be left with x plus 5. Okay? I really like factoring. When you're stressed, go home and factor. It'll make you feel better, right? Okay, cool. Let's try this one. X squared plus x minus 30. X squared plus x minus 30. So I'm looking for two numbers this time to multiply to negative 30, but add together to give me positive 1. So that's actually still going to be my 6 and 5. It's just that now the 6 is positive and the 5 is negative. Okay. So again, I'm going to take a look at this and I'm going to say, okay, let's factor the front two, factor the back two. Okay. So what can I take out of an x squared and a 6x? I can take out an x and I'd be left with x plus 6. In the back term, I would take out a negative 5. If the front dude is negative, you always want to take out the negative. Okay. So taking out a negative 5, I'd be left with x plus 6. That makes me super stoked because I've got x plus 6 on both terms. I can pull that x plus 6 out to the front, and I would be left with x minus 5. Okay? Awesome. Oh, sorry, I gotta take that off. X squared plus 11 plus 30. Okay, again, looking for two numbers that multiply together to give me positive 30 and add together to give me 11. So I'm going through my factors of 30. I can write them out for you if you like. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Oh, look at that. 5 and 6 add up to 11. Okay, so I'm going to break my 11 into 5x and 6x. And then I'm going to factor the front two, factor the back two. What can I take out of an x squared and a 6x? I can take out an x. What can I take out of a 5x and a 30? I can take out a 5. Okay, in both of those conversations, I'm going to be left with x plus 6 in the brackets, which is awesome because that means x plus 6 is a common factor. Pull that to the front, and then I'll be left with x plus 6 times x plus 5. All right, we're rocking this. I just keep forgetting to turn that off. 2x squared plus 3x plus 1. So looking for two numbers that multiply together to give you 2 and add together to give you 3. Well, that's 1 and 2. Okay, so I'm going to decompose. I'm breaking my 3x down into 2x and 1. Okay, and then I'm, again, thinking about, hey, I'm going to look at the front two. I'm going to look at the back two. What can I take out of the front two? I can take out a 2x. And I'd be left with x plus 1. In the back two, I can't actually take anything out, but I have to take something out to finish the process. So what I do is I just take out a plus 1, and that leaves me with x plus 1. I get super duper happy because I see x plus 1 is common to both. Okay, so the x plus 1 pulls to the front, and I'd be multiplying that by what's left, which is the 2x plus 1. Okay. Is this feeling okay? Are you feeling better about factoring? My goal is you spend some time with me and you feel better, not worse. If you're feeling worse after spending some time with me, hey, give me a heads up and let me know that so I can think about what to change, okay? All right. 3x squared minus 7x plus 2. So now I'm looking for two numbers that multiply together to give me 6 and add together to give me -7. Well, if I want to multiply to be a positive number, either both my numbers have to be positive or both my numbers have to be negative. If I want to add two numbers and get a negative number, that tells me both my numbers have to be negative. Okay, so I'm thinking about -1 and -6 here. -1 times -6 is +6. -1 plus -6 is -7. Okay, so I'm going to break down my -7x into -1x and -6x. Okay, then again, I'm looking at, okay, time 2, factor the front 2, factor the back 2. So what can I take out of a 3x squared and a minus x? That would be an x. Pull the x to the front, and I'd be left with 3x minus 1. I feel like I want to do that with you. Okay. Probably because I really like this blue. I don't know why. -6x plus 2. Remember, if the front dude is negative, you are always taking out the negative. And then between a 6 and 2, I could take out a 2. Okay, so I'm going to take out a -2 and say what's left. -6x divided by -2 is +3x. And then 2 divided by -2 is -1. That makes me super excited because I see the same thing in the brackets. Pull that to the front, and that's going to end up being multiplied by x minus 2. Okay. Yay! All right. Let's try 5x squared minus 22x plus 8. So again, I'm looking for two numbers that multiply together to give me 40. Add together to give me -22. So again, they're both going to have to be negative. So let's think about it. 1 times 40, 2 times 20, that'll do it right there. Look at that. -2 and -20, -22. So I'm going to break down my -22 into -2x and -20x. And then I'm looking at, okay, time to factor the front 2, factor the back 2. Out of the front 2, I could take out a 5x. And that would leave me with x and -4, 20x divided by 5x. Out of the back 2, I would take out a -2. And that would be x minus 4. Again, I really want to stress when you take this number out, it's super important that there's either a subtraction sign or a plus sign there, depending on whether it's positive or negative. Okay. Okay, then the x minus 4 is the same, so it can be pulled to the front. And what will be left over is my 5x minus 2. Okay. Yay! Okay, 2x cubed plus 3x squared minus 3x. Again, first thing we should do, take out a greatest common factor, okay? Each one of these guys have an x involved, so I can take 1x out, and that would be left with 2x squared plus 3x minus 3. I then think, okay, can I look for two numbers that multiply together to give me -6 and add together to give me 3? Well, I've got a 1 and 6. There's no way to get 3 out of that. And I've got a 2 and 3. There's no way to get 3 out of that. And that's it. Those are my only factors of 6, which means no, this was the intent of the question, was just to take out the x. There is nothing further I can do here. I have completely factored it. Okay, there's nothing else to do. All right. Factor so that the leading coefficient is positive. Now, the definition of a leading coefficient is the number in front of the variable with the highest exponent. Now, if it was written in the right order, that would always be the first guy, and that's why it's called leading coefficient, okay? But this is not written in the right order. Remember, we write polynomials from highest degree to lowest degree. So this is the leading coefficient. So let's get it in the right order first. And then what we're going to have to do, if we want that to be positive, we're going to have to factor out a -1. So if I factor out a -1, that switches the signs on both of these guys, and then we're good to go. Okay. Okay, so -15x cubed minus 5x, that is written in the right order. The leading coefficient is on x cubed, and it would be -15. So I want to factor out a -1. I could also factor out a 5x. So let's factor out a -5x. And when I divide out when I divide -15x cubed divided by -5x, that will leave me with positive x squared. And then when I take -5x and divide by -5x, that leaves me with +1. Okay, a reminder, there's actually nothing else I can do with this. Even though you see a perfect square and a perfect square and you start getting excited, it's not a difference of squares, it's an addition of squares. And so we can't take that any further. Okay. Okay, 3x minus 9x squared. The 9x squared is your leading coefficient, so we want to take that negative out of there. We'll write it in the right order first. And then we're going to take out, well, for sure, a negative. We could take out an x as well. And what's common between 9 and 3? That would be 3. We could take out a 3. So altogether, let's take out a -3x. That would leave me with -9x squared divided by -3x is 3x. And then careful, 3x divided by 3x will give me 1. -1, sorry, I was dividing by -3x. Okay, so a positive divided by a negative would give me a negative. All right, cooking along here. You guys are doing awesome. 9 minus x squared. The leading coefficient here is -1. It's on the x squared. Let's get it written in the right order. Then I'm going to factor out a -1. So -1 bracket x squared minus 9. And then, friends, what do you see? What do you see? I see a difference of squares looking at me. So that's going to be x plus 3 and x minus 3, right? We take the square root of x, that becomes the front dude. We take the square root of 9, that becomes the back dude. Okay? All right. How do you solve these equations? Now, you did a little bit of this in grade 11, so just a quick review. The first step is we want to factor it, okay? So we are thinking about decomposition right now. We're looking for two numbers that multiply together to give me -30 and add together to give me -1. We've actually factored that question in our note already. That happens to be -6 and +5. So I break down my -x into -6x plus 5x. I'm going to factor the front two, factor the back two, just like I was doing previously. Okay. The only difference right now is now we've added to our statement that this equals 0 at the end. Okay. But I'm still going to factor the front two, factor the back two. I can take out an x and be left with x minus 6. I can take out a 5 and be left with x minus 6. And so very quickly, I get down to x minus 6 times x plus 5 equals 0. Friends, can I just warn you right away, this equals 0 is incredibly important. It needs to be on every line, okay? Math is very big on proper communication. And what I'm about to do, I can't do mathematically unless it equals 0. Because what I'm about to do is use something called the zero product principle, okay? The zero product principle states if two numbers multiplied by each other equal 0, then either one of them could be your 0. So I'm going to say that means, well, x minus 6 could be my 0. And if that's the case, I add 6 to both sides and say that x equals 6. Or x plus 5 could be my 0. And if that's the case, I'll subtract 5 from both sides and say that x equals -5. Okay, now I'm going to state these in solution set brackets. So I'm going to say x equals squiggly bracket -5 comma 6. When we write them in solution sets like that, they should be in order from smallest to largest as well. Okay. All right, let's try another one. X squared minus 11x plus 30, looking for the solution. It equals 0. So essentially, we're trying to find the x value that will make this equal 0, right? So looking for two numbers that multiply together to give me 30 and add together to give me negative 11, that would be negative 5 and negative 6. So I'm going to decompose my negative 11 into negative 6x and negative 5x. I'm going to factor the front two and factor the back two. What can I take out of an x squared minus 6x? I can take out an x and be left with x minus 6. What can I take out of a negative 5x and a 30? I could take out a negative 5 and be left with x minus 6. Pull my x minus 6's out to the front and be left with x minus 6 times x minus 5 equals 0. Now I have the zero product principle. I have a number times a number equals 0. Either one of those numbers could be 0. So I have a statement that reads x minus 6 could be 0, or x minus 5 could be 0, which tells me x could be 6. I just add 6 to both sides. Or x could be 5, adding 5 to both sides. And then I conclude in solution set brackets, x equals squiggly bracket 5 comma 6. Okay. All right, friends, you're doing awesome. One more equation to solve. X squared plus x minus 30 equals 0. Looking for two numbers that multiply together to give me negative 30. Add together to give me 1. Okay. So that would be 6 and negative 5. So I decompose. I'm breaking that x term down into 6x and negative 5x. Going to factor the front two, factor the back two. Out of the front two, I can take out an x and be left with x plus 6. Out of the back two, I can take out a negative 5. That'll leave me with x plus 6. I get super, super excited because I have x plus 6 common to both of those now. Pull that to the front and then multiply that by x minus 5. Don't forget your equals 0 each time. Okay. And so now I have x plus 6 equals 0 and x minus 5 equals 0, which means I subtract 6 from both sides and get x equals negative 6. I add 5 to both sides and get x equals negative 5. And then I write that in solution set brackets. Now, I just don't want you to lose what is happening here. You were asked to solve these equations. What is this telling you? This is telling you that there are two values for x, that if I plugged in negative 6 into here and here, I would get out 0 in this question. It would be a solution, okay? Or if I plugged in 5 here and here, I would also get out 0. If I plugged in any other number but negative 6 or 5, I would not get out 0. It would not be a solution to the equation. Okay? All right. That, my friends, was a very quick review of some factoring skills. I hope that that was helpful to you and that you're feeling okay as we kind of jump into this unit. In the next video, we'll talk about equivalency and non-permissible values. It'll be super fun. Hey, thanks for watching this. I hope it was helpful. And thanks for sharing these videos with your friends and for letting them know that this is available. And thanks for your subscription. I really appreciate it. If you have any questions, feel free to connect with me. You got this. Have some fun factoring now. Take care, guys.